3.3 for Algebra 2, Systems of Inequalities. So we are going to solve systems of linear inequalities. Just one thing to learn today. And actually no new vocab either. But there are a few skills that we need to be able to do. So we'll start with those. Go ahead and just pause this video for a few minutes, take a few seconds, and see if you can solve these. All right, for the top three, get x and y by themselves, and on these you're going to graph these and you're either shading above or you're shading below. Okay, so pause this, try those problems, and I'll put up a few answers here in a second. Okay, let me put up 1. If you did 1 correctly, 5x minus 6 is greater than 27. We would add 6, and we would say 5x is greater than, let's see, what do we got here? 33. And so x is greater than 33 over 5. And it didn't say to graph it, so we're going to leave it just like that. And let's take a look at, you know what, I'm going to do number 9 down here. Let me do the hard one. On here, we've got an absolute value graph, and our vertex is going to be at, remember, negative b over m? So we've got negative 2 over 1, comma, c, which is 4. So 2, comma 4 is our vertex. And on this one, if I plug in 0 for x, I'm going to get the absolute value of negative 2 plus 4, which is 2 plus 4. So if I plugged in 0, I got out 6, 0, 6. And because of symmetry, I also have this point. And so this is going to be a dotted line, remember, because of the equals. And since it's less than, we would shade below this graph. Okay? Alright, so we'll go over the rest of those in class. But for now, let's move on and learn how to solve systems. So, solving systems works just the same as what we just did here. For 9, right, we're going to draw our graph, but in this case we're going to draw 2 of them and find the area where we would shade for both of them. Alright, so here's what we're working on. For the first one, I'm going to go y by itself. So negative 2y is less than negative x plus 6. Divide by negative 2. So y, got to switch it, x over 2 minus 3. That's what we get if we divide by 2. All right, I'm going to go ahead and graph this line. Go down 3, 2, 3, make a dot. From there, I'm going to go up 1 and over 2. So right there. And we can go ahead and connect these with a dotted line. I'm going to make a couple more dots just so I can make a nice connected line. Should go through there. Okay. And I'm going to wait on shading just for a second until I have my next line. And the next one here is ready to go. I'm going to go up 5. 1, 2, 3, 4, 5. I'm going to go down 3. 1, 2, 3, and right 2. Down 3, right 2. It intersects. Down 3, right 2. Alright, so I've got my second dotted line. Okay. I need to be above the first line. You don't have to draw out all these little arrows, but I'm just putting them in there so that we can see it. Above that first line. And we would need to be below, oh, sorry, forgot my solid line. Should have been solid because it's got an equal line. Missed that one. Right? It's got an equal, so it's solid. And I want to be below that line. So below, 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 below. All right. So if we look at this, this kind of makes it an X, right? And so we've been split up into 4 different regions here, right? We want to be in the area that both lines work for. So in this region, we'll call this region here 1, we're above, so that works, but we're not above this line, so no good. Okay, if we go to the second region, we're below this line, We're above this line, so that works. We want to be in this region here. Okay, so we would shade that whole area in. All right, so that is what we're looking at for this section. That's kind of the bulk of everything that we're doing. So take a minute, see if you can draw these, and remember what kind of line x equals is for 1a. Try those, pause it, and when you're ready to move on to the second example, come on back. All right, a word problem, our good friend the word problem. An entrance exam has two parts, verbal and math. You can score a maximum of 1,600 points for admission. Oh, so this is the old SAT. This is when I took the SATs. It was only worth 1,600. For admission, the school of your choice requires a math score of at least 600. Write a system of inequalities to model scores that meet the school's requirement. Then solve the system. Okay, so let's start with just the total score. So we can get 1,600 total. So your score has a verbal part. We'll call that X. And a math part, we'll call the math part Y. So X plus Y has got to be less than or equal to 1,600. Right? Your two scores have got to be 1,600 or below, right? Because there's no way to score more than a perfect. All right, the school of your choice requires a math score of at least 600. So the math part, Y, has got to be at least, so bigger than or equal to 600. All right, let's go ahead and graph this. I'm going to count by, 200s. So 200, 600, 800, 1,000, 1,400, and the next tick mark out here would be 1,600. 2, 4, 6, 8, 10, 12, 14, I need one more, 1,600 up here. All right, so I can do intercepts here. If I cover up X and Y, it would be 1,600 and 1,600, and we can connect those with a solid line. And we know that Y has to be bigger than 600. 2, 4, there's 600, and so solid line across that one. All right, now I know I need to be above above the Y line, but below this line. So here we go, we're going to be right in this nice little slice region here. And I'm actually going to stop drawing in here because does it make sense to get a negative score on the SATs? I hope not. I hope we're not getting negative scores on our SATs, and nobody in our math class will get negative scores on the SAT because it's not possible. Okay? All right, so try to figure out understanding check number 2, thinking the same way. Graph this thing, system of inequalities. All right, last one. We're going to bring back our old friend, the absolute value. So here we go. Y is less than 4. 1, 2, 3, 4, and dotted line going straight across. Y is greater than or equal to X minus 3. This is going to be a vertex of 3 over 1 and 0. And we're going to have a slope of 1 and 1, solid lines. Going up. All right, so we need to be below the dotted line and above the solid line. So we should be in this region here. This nice little triangle. All right, and I believe that's it for this section. Just 3 example problems. Yes, there it is. So there's understanding check number 3. Knock those 2 problems out, and we'll go over everything in class.